Hey, welcome to your first at-home math lesson video. We're going to be talking about 1.1 bridge thickness and strength. So we're going to look at how the bridge thickness affects the bridge strength. Now clearly you probably have some ideas about what's going to happen the thicker the bridge becomes related to how strong it is, but we're going to test it. Now for this experiment, here's what you're going to need. You're going to need a piece of standard paper. I have graph paper here because it's going to really help me because it's already measured in 1/4 inch squares. 4 1/4 inches equals 1 inch, so that's going to make life a little bit easier for us in a moment. We also need 2 supports of identical size. We're going with geometry because it can be the foundation of math to come. Okay, that's a bad math teacher joke. We'll have a small Dixie cup. Mine's clear, so it's hard to see. So my pennies are going to look like they're going to be floating. Now, here's what we're going to be doing. We are going to take our standard piece of paper, and we're going to fold it in half, just like this. And we're going to make sure it's a good fold. We're folding it hot dog style. To be honest with you, I vastly prefer hamburgers to hot dogs, but for this, hot dog style is going to have to be the way to go. And I'm going to fold it over to make sure my edge is nice and sharp. I'm using my nails here. I'm going to fold it over again because if you're going to do something, you might as well do it right. And so now I have this nice fold. And so I'm going to take the tip, break it apart a little bit, and gently pull down to cut the paper into 2 identical halves. That is my first magic trick of the year. You'll get pretty good at it pretty soon. Then we're going to make a bridge out of this piece of paper. Now, if I were to put this piece of paper on the 2 supports, it's not staying, is it? It's not even strong enough to hold up its own weight. By the way, the weight of an object, of a building that is supposed to support other things is called the dead weight. Live weight is the weight of the building, the weight that the building has to hold. So right now, this bridge can't even hold up its own dead weight. How is it supposed to hold up pennies? Well, paper is actually a pretty cool material because I can change it very easily so that it does have strength. So I'm going to look onto my grids, and I need to fold up 1 inch. So I'm going to count 4, 1, 2, 3, 4 little squares. I'm going to fold over my paper. I'm going to make sure it's a nice straight. Look at that, that's pretty good. And then I'm going to do the same thing on the other side. I'm going to count 4 squares, fold it over. Miss Stoddard just came in asking about what are bridges, how can they have 15 bridges? Well, this is a bridge. I mean, granted, it's not a bridge that I would want to walk over, but it's going to be a bridge that is going to be strong enough to hold some pennies, hopefully. So right now, we have, look at that, it's a bridge. Okay, so now when I place it on the 2 supports, look, it can hold its dead weight. Now, this is very important. To do an experiment, we have to make sure the variables are controlled. So we are going to have exactly 1 inch on either side of the support. So I'm going to look at my grid paper again and count 4, 1, 2, 3, 4, and make sure the line of that 4th square is along the edge line of the book. Then I'm going to do the same thing on the other side, 1, 2, 3, 4. All right, so now I have my bridge that's spanning, well, if this whole thing's 11, I have an inch here and an inch here, that's 2 inches, 9. So we have a 9 inch span here. So this is 9 inches between the 2 books. All right, so what I'm going to do is I'm going to take this little cup and I'm going to place it directly in the middle of my bridge. It holds, that's great. Then I'm going to take my bag of pennies and then I'm going to take 1 penny. Now, remember, we want to control for all the variables. So, we want to drop the pennies exactly the same every time. So I'm going to take my penny to the lip of my cup. Now, granted, my cup is hard to see, but you'll survive. And I'm going to drop it from that lip height. 1 penny. Now, is this bridge holding 1 penny? Yeah, kinda. So we're gonna say it held 1 penny. Let's see if it holds 2. This one's shiny. It's hit the floor. So here's the question. How many pennies, or what is the breaking weight for this bridge? Well, it only really held 1 penny and it broke with 2 pennies. So here's what we're gonna do. You're gonna make a table. That's not making a table. And we're gonna have 2 variables, the independent variable and the dependent variable. And remember, the independent variable always has to be listed first. You should have learned that in 7th grade. Independent variable has to be first. So that's on the left side of a vertical table, or it's on the top of the horizontal table. So the dependent variable, independent variable. Well, I'm not going to write independent variable here because we have a variable. So does the breaking weight depend on the thickness, or does the thickness depend on the breaking weight? Discuss amongst yourselves. Definitely, you're right. The thickness of the bridge will determine how strong the bridge is. So we are going to put bridge thickness. I'm going to put T for thickness, and I'm going to make a note of that. T equals thickness. And we're going to have breaking weight, B for breaking weight. And it's important to define your variables here. All right, and well, okay, so I had 1 layer of thickness, and how many pennies did it take to break it? Well, it took 2. Well, we're going to continue this, obviously. We're going to go with 2 layers of thick, 3 layers thick. What comes after 3? 4. And we're going to go all the way up to 5 layers of thickness. Now, that is what you're going to have to be doing. But there's some more parameters we need to talk about before I just say, go build. Here are the parameters we need to talk about. Well, if I were to take this piece of paper, and look at this. If you look closely, this bridge now has this wobbly piece into it, and it's in both sides. That's where the bridge buckled. Once this piece of paper has a buckling point, this piece of paper will no longer be able to hold the same amount of weight it once did. It's done and over with. You can't use it again. If I compare that with, oh, look at that magic, a bridge that I have not used yet. Granted, this I haven't folded it back. But notice how these fins tend to be much straighter. So this has not been used. This has been used. Once you have used your bridge, it can't be used again. So you're going to crumple it up. Don't tell your parents I said this. And you're going to chuck it at your sister. Okay. So when you have 2 layers of thickness, whoa, look at that. Woo. We are going to put the 2 bridges one on top of each other. So now we have 2 layers of thickness, but same thing here. So here's what I need you to do before class starts. I need you to make sure you have some pennies. You can start with 1 layer of thickness, 2 pennies. We will all use that for our starting point. And notice how in my table I have a open space here. Bet you can't figure out what belongs there. And then I need you to make bridges, enough bridges, so that you can have 2 layers thick, 3 layers, 4 layers, and 5 layers thickness. That means if you can't reuse the bridges, you need 14 more bridges. Well, if each piece of paper can make 2 bridges, then that means you need 7 pieces of paper cut into half and turned into bridges. The expectation is on Tuesday, I will see you with your bridges, your supports, your cup, and your pennies. And a table's a good idea too. Might as well get it started. With that, I hope this was an easy first day of homework, and I will see you tomorrow.